You learn that with quadratic probing, we may end up with an infinite loop because the algorithm generates the same steps. 149, and then we might jump to the beginning of the array, again 149, and so on. This is where double hashing comes to the rescue. With this algorithm, instead of I or I squared, we use a separate independent hash function to calculate the number of steps. Here's a popular second hash function. This prime we have here should be a prime number smaller than the size of our table. Now, where does this come from? Honestly, I don't know, but experts have figured out that this formula works well. Here's how we can calculate the index using the double hashing algorithm. Don't panic, it's actually easier than what you think. So just like before, we start with an initial hash value. Now we need to calculate the steps. Previously, we used I in linear probing or I squared in quadratic probing. Now we're using I times the second hash value. That's the only difference. Finally, we should apply the modulus operator to reduce the result. Now let's see this in action. So we have a hash table with 5 empty slots. Here's our initial hash function, the one we have used in all examples so far. Here's our second hash function. As I told you, the prime should be a prime number smaller than the table size. So in this example, we should use 3. And here's our formula for calculating the index. We start with the first hash. If that slot is full, we add I times the second hash to it. And finally, we reduce the result to fit the table, okay? Now we want to store this key value pair. We give the key to our first hash function. It returns 1, so we should store it at this location. Just like before, nothing new so far. Next, we want to store this other key value pair. We give the key to our hash function, and it returns 3. So we store this key value pair at index 3. No collision so far. Now we want to store this new key value pair. We give the key to our first hash function. It returns 1, but we already have an item at this location. So we have a collision. And that means we should probe for an empty slot. Previously, when using linear probing, we just looked at the following slot. With quadratic probing, we used I squared to make big jumps. With double hashing, we use I times the second hash. Let's see how this works. What is our second hash here? If we pass 11 to our second hash function, we'll get 1. Now let's put these values in the index formula. The first hash is 1, I is 1, and the second hash is 1 as well. So the result is 2. And we should store this new key value pair at this location. Now, what if the slot was full? Then we increment I until we find a new empty location. This is how double hashing works. Now, in this particular example, again, we have a cluster, but this is because we are working with a very small array. For a larger array, you will see that these key value pairs will be spread out. They won't be next to each other. Now let's review all these probing algorithms. As you can see, in all these algorithms, we start with an initial hash value and then add a number of steps to find an empty slot. In linear probing, we use I. In quadratic probing, we use I squared. And in double hashing, we use I times the second hash.